Okay, this is from the sheet that says 5641. Number one we already did in class, so this is number two. And this question is asking about increasing and decreasing. So this was the function, and we're going to take the derivative. And we're going to set that equal to 0. Then we're going to solve for x. Okay, so now we're going to make our wiggle graph. And then we're going to substitute different values into the derivative. When you do that, you will get these signs. Okay, so the function is increasing from negative infinity until it gets to negative radical 2. And it's also increasing from radical 2 to infinity. It's decreasing from negative radical 2 to positive radical 2. Okay, the question is asking about a whole bunch of different things. So let's look at our choices. So A says that it's increasing for all values greater than radical 2. So greater than radical 2 would be, let me get another color, this piece right here. It is increasing, and then it's decreasing for all values of x less than radical 2. Well, these would be the values less than radical 2, and those are increasing, not decreasing. So therefore, A cannot be the answer. Okay, so we'll take that out. Okay, let's look at choice B. B says that it's increasing for all values of x. But we can see right here there are some values where it's decreasing, so it could not be B. So we'll take that out. Okay, now we'll go to C. So C says it's increasing for all values that absolute value of x is greater than radical 2. So greater than radical 2 would be right here, and yes, it is increasing. And it's decreasing for all values of absolute value of x is less than radical 2. So I'd just like to thank Mark for this, because actually during tutoring we talked about this, and he actually explained it to me because I was getting so confused by the notation. But let me just erase this part here. Okay, so it says that it's decreasing when the absolute value of x is less than radical 2. So, like, when would the absolute value of x be less than radical 2? Well, what about something like if x equals 1? The absolute value of 1 is less than radical 2. Okay, so let's look at the value of 1. And 1 would fall in this category, which is decreasing, so it worked. If you chose, I don't know, let's say x equals, I don't know, 1/2. Like, you have to find values that the absolute value of it is still going to be less than radical 2. And when x equals 1/2, you're also in this interval. And you could keep trying things and you'll see that it totally works. And therefore, the answer is C. Okay, let's go to number 3. So this is the function. And we're interested in when is it increasing. Okay, so we're going to do what we've done, and we're going to find the derivative, set it equal to 0. So this is going to be a quotient rule. So it's the bottom times the derivative of the top. Okay, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so we're going to set that equal to 0. So just in the interest of space, I'm just going to erase this and write it as 0. Then we're going to cross multiply. And we're going to get that disgusting numerator. Maybe I could write it a little bit nicer by distributing a little bit. If I take this -1 and I put it over here, I'll get a -1, which is positive. Okay, so that it's just that equals, so this is where I got it from. So I did 1 times this, which gives me this whole mess, and then 0 times anything is equal to 0. Okay, so for what values is this increasing? So if you wanted to try and solve this would take you like forever to do. So thankfully, this is multiple choice, and they're giving you all these answers. So what we're really interested in is -1, 0, and 1, because if you look at all the choices, that's what they're all around. So we'll make a wiggle graph, and we'll put -1, 0, and 1. So if we choose, let's say, f prime, of -2. Okay, so remember, all we want to do, let me just box this, I'm sorry, it's just getting so messy, it's looking ugly. This is the derivative right here. Okay, so we're going to plug values into that, and just see if they're positive or negative. Okay, so if we put -2 in there, this first set of parentheses would be 1 minus -2, which is 1 plus 2, which is 3, so that's a positive value. That's all we care about, if it's positive or not. Okay, the next set of parentheses, if I put -2 in there, I'll get -8 times 2 is a -16 plus 4. That's going to be a negative. And the next one is going to give me 12 minus 1, that's positive. Okay, and so that all these signs came from this whole first, let me get another color, came from this whole piece right here. Okay, and then we have a plus, and this whole second term, that's always going to be positive because it's to the second power. So we have a positive times negative is negative. Negative times positive is positive. I'm sorry, that's totally wrong. Positive times negative is negative. A negative times positive is negative. Sorry. It's late and I worked all day. Plus a positive. Okay, so this is a problem because now we're going to have to actually figure out the numbers to see if it's positive or negative. See, if it was a positive and positive, then we know it's got to be positive. So, unfortunately, oh my goodness. Okay, I just looked at this problem better. You're probably all saying, what an idiot. Okay, I'm going to have to agree with you. Well, this is a good lesson to be learned, that you should be reading the problem carefully, because if you did, you would see I did all this work for nothing, because the function they gave you was the derivative. So the derivative is equal to this. I thought that was the original function. Okay, sorry. All right, I'm setting that equal to 0. This is going to look a lot nicer. So you get this equals this. Okay? And now we can do what I was doing before. So -1, 0, 1, and we're putting it into f prime. Okay, so what is f prime? It is this. Okay, so if you do y prime of, let's say, -2, on the top, you're always going to get a positive value because it's squared, and on the bottom, you're going to get 1 minus -2, which is going to give you a positive. Positive over positive is positive. Okay, if we do y prime of, let's say, -1/2, we know the numerator is always positive, and on the bottom, we're going to get a 1 plus 1/2, positive. Okay, this is like the problem Patrick did in class for the class, where it's a lot easier if you just use some common sense and say, well, my numerator is always going to be positive, so I really just have to worry about the denominator. Okay, now if you do y prime of positive 1/2, you're going to get a positive in the numerator, and in the denominator, you get positive again, and that gives you a positive. And then finally, y prime of, let's say, 2, you'll get a positive in the numerator, a negative in the denominator, so you're going to get a negative. Okay, so what has this wiggle graph told us? Let's make some room. So what we know is that from negative infinity until it gets up to 1, this function is increasing, and then when it gets from 1 and it keeps going, it is decreasing. So let's look at our choices. Okay, so it's asking when is it increasing? So this is what we're looking for. So A says it's increasing from 0 to 1. Well, if you look for when it's increasing, which is here, 0 to 1 is included in there, so A is in the running. B says it's increasing when x is less than 0. Okay, that's not true because 1 is not less than 0, so B's out. C says it's for when x is greater than 1. That's not true. D says when x is less than 1. Okay, that one's looking good. And E says between -1 and +1. And that one also looks good. So if you had to choose one of them, I would go with, because lots of times these problems, there might be more than one answer, but you're picking the best answer. This has got everything from x less than 1. So I would choose D as the answer. Even though the others are also correct, the one that's more thorough would be choice D. Okay, let's go to number 4. Okay, so the original is this. And we're going to find the derivative, which is a quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so we're going to set this equal to 0, and I'm going to just simplify as I'm doing that. Okay, I'm going to make a little bit of room. Okay, I'm going to cross multiply. Okay, I can factor out 2x. So I get two solutions. I get x equals 0, and I get x equals 3. Okay, so let's see, this was the derivative right here, that boxed part. Okay, so let's do f prime -1. Okay, so if I put a -1 in there, I'm going to get 2 minus 4 minus 6 over a positive number. So I will get a negative over a positive, which is negative. Okay. Let me make some room up here. Okay, if I do f prime of 1, I'm going to get 2 minus 4 plus 6 over a positive. So that's going to be a positive over a positive, which is positive. And then if I do f prime of 4, I'm going to get 32 minus 64 plus, oops, plus 24 over a positive. So that's going to be a negative over a positive is negative. Okay, so let's see what this is telling us. The question is asking, when is this increasing? So it's increasing from 0 to 3 according to this wiggle graph, and that is choice C. Okay, so we got 2 more to go. Let's go to number 5. Okay, the original function is this. There's no negative here. I'm just getting sick of this color. I'm going to change it. Okay, we're interested in decreasing, so we'll find the derivative. I'm going to set that equal to 0. Factor. Get our solutions. Okay, this can't be, so there's only one solution, x equals 0. So this was the derivative. So if we do f prime of negative 1, we'll get negative 8 minus 8, negative. And if we do f prime of 1, we get 8 plus 8, positive. Okay, and the question is asking, when is it decreasing? So it's decreasing from negative infinity to 0, and that would be choice D. Okay, and we have one more question, number 6, and we'll be getting into this topic much more next week. So they're showing you a picture of the derivative, and it looks something like this. I'm just going to kind of hand draw it. So you can see from negative 2 until it gets to 0, this derivative, f prime, all the y values are positive. It's greater than 0. So that means the slope is positive. If the slope is positive, that means that f is increasing from negative 2 to 0. Then, from 0 to 3, you can see all the values of f prime are less than 0, so that means the slope is negative. So when the slope is negative, that's because f was decreasing from 0 to 3. So the question is asking, when is it decreasing? That would be here, from 0 to 3, and that is choice E, and that finishes the sheet.